Hi guys, how are you today? Today we're going to look at the what is the solar panel system power output, guys. After the all the efficiency we calculate. So guys, as you know that the solar panel have the efficiency itself, but overall system efficiency if we calculate in the real world. I already made a video on the solar panel efficiency how it works, but here I want to talk about the overall system in the real world. So guys, imagine my system is a 5 kilowatt, guys. 5 kilowatt. If somebody have vision, now I write for the red pen. Yeah, 5 kilowatt. So guys, the 5 kilowatt system, if somebody think about it, like 4 hour they receive the sunlight. So the 4 hour if they receive the sunlight, that mean 20 kilowatt hour. 5 kilowatt times 4, 20 kilowatt hour. But guys, if we calculate the losses, guys, that's very important, guys. Lot of losses we have in the real world. So what are the losses? We look at in the next slide. Is the on grid. I will come to this slide. But here, I want to talk about the manufacturing losses, guys. During the manufacturing of solar panel, some of the like quality issue occur. So we assume that 3% loss in the manufacturing. Another is the dirt loss, guys. Lot of dust on the solar panel, guys, because of the wind, because of the climate. Lot of dust on the solar panel. So we assume that 2% loss of the dirt loss, and another is temperature derating. So what the guys temperature derating, guys? A lot of people think that the temperature derating about. So temperature derating, guys, sunlight here, guys. But the sunlight, because of the cloudy sun rays, little bit not coming properly because of the cloudy environment. So sun also solar panel received the less irradiance from the sun because of the climate as well. And a lot of people have the misconception that if more solar, like the more temperature, that means more power. No, guys. Here is the graph, guys. Here is the graph. I draw here, guys, graph. Let me draw the graph here. This is the graph, guys. This is, I assume that's a power output. This is the temperature, guys. So imagine if I have average temperature here, yeah, temperature. So the graph is like this, guys. After certain, if you can't see, I draw here. After the certain temperature, guys, let's imagine temperature is 40. So what happened, guys? Let's imagine temperature is 25. So what's the power output, guys? Here is the power, yeah, power output. So on a 25 temperature, guys, is here. When solar panel received more temperature, guys, it start to fall, guys. Giving the efficiency, it's falling because more heat solar panel received and more losses occur. On the average temperature, guys, 25-30, solar panel works very nice. Efficiency very high, guys. But once the solar panel received more temperature from the sun, and lot of solar panel become very hot. If you want to think about your mobile phone, let's imagine when your mobile phone become too much hot, so your sometime some mobile phone automatically shut down because of the heat, guys. So same thing here as a temperature reading. So it's very high guys. Temperature derating is 12% guys. AC cable loss guys, and inverter efficiency I will look at in upcoming slide, and the DC cable. What's these three losses? AC cable, inverter efficiency, and DC cable. So I want to look at you here in this slide. So the panel produce the DC power, and the inverter, it goes to inverter to convert the AC power, because our home all of lot of appliances depend on the AC power. So what happened guys here? This wire has a 2% losses. The inverter itself has a 5% losses, and the inverter to our meter, the wire is a here wire guys. Cable, we can call cable. It also has a 2% losses guys. 1%, 2% losses guys. See here. So this cable, yeah. Now guys, my system is 5 kilowatt. 4 peaks an hour. If you want to know about the peaks and hours, you can watch my video about the peaks and hours. Peaks and hours is a guys solar panel. The sun, whenever in the morning and the afternoon, during the time solar panel receives the highest irradiance from the sun. That's we call the peak hour, peak sun hour. During the evening time, we have the sun, but the solar panel received very less irradiance from that sun because of the angle of the solar panel. In the evening, as you know, the sun is on the angle. So for my peak sun hour, I assume that. So total, I think about the 25 times 4 is 20 kilowatt hour. My system is. But guys, if I calculate these losses, let's say manufacturing loss is 3%. So 100 minus 3 is 97. Dirt loss is 2%. Temperature derating guys is 12%. So these all the losses I here assume. Here I assume all the losses. Approximately 25% losses guys. How much? 25% in the system. This is theoretical. In the real world, more or less approximately 25% guys. So what happened next? What is my actual power after calculating all this stuff? We people assume that their solar panel produce 20 kilowatt hour. No guys, that solar panel produce is 15 kilowatt hour. How? You can now see here. 5 times 420 times 0.09, 0.095, 0.98, 0.988, 0.98, 0.97. Yeah, all the calculation we got it 15 kilowatt hour per day guys. If I want to calculate for the year, now I have to multiply 15 times 365. So I got per year. So I hope today you guys learned something. If you want to learn about the on-grid and off-grid solar panel, you can watch my video about this. In the off-grid solar panel, we have two more losses: the battery and the um, charge controller. So guys, if you want to look at about this, the battery is here guys, coming here. If you want to store your solar panel power, and the battery is the battery here. Before the battery, we have the charge controller guys. Charge control the prevent the battery from the overcharging guys. So we have two more losses guys in that one. So maybe here more 15% losses more maybe because of the charge controller and the battery. But if you want to know about the off-grid and on-grid solar panel and the peak sun hour, you can watch my video I already made on the video. Thank you so much guys for watching the video. Have a good day. Enjoy guys.